right, so today we're talking about relative frequency, and again, this all fits into the realm of probability. So, first of all, what is relative frequency? Well, relative frequency is going to be a ratio comparing your favorable outcomes to your total outcomes. Okay, so relative frequency, I'll just kind of write this up top here. Relative frequency is favorable, I'm just going to abbreviate, favorable outcomes. So when we say favorable outcomes, if I'm talking about, okay, so what was the relative frequency that the coin landed on heads? So I'd look at, okay, I flipped the coin this many times and it landed on heads 4 out of the 10 times. So the 4 times that it landed on heads would have been the favorable outcomes that I was looking at, that I was wanting to look at over the total outcomes. So I use the example of like flipping that coin, right? So I said it landed on heads 4 times out of 10 trials, right? So 4 is the favorable outcomes because I was looking at how many times was it on heads. And then the total outcomes in that case was 10 because I had flipped the coin 10 times, right? So example 1 says a random number from 1 to 5 is selected 50 times. So 50, that's going to be your total outcomes. There's 50 things that could have occurred, right? There's 50 total outcomes that could have happened each time that random number was picked. The number 1 is selected 13 times, 2 is selected 8 times, 3, 14 times, 4 selected 6 times, 5, 9 times. What's the relative frequency of a 2? And then what's the relative frequency of a 3? Okay, so first of all, let's talk about the relative frequency of a 2. Well, so how many times was a 2 selected? It was selected 8 times out of, so that's your favorable, out of the total. Well, there's a total of 50, right? Because there was 50 times, there was 50 trials, so it'd be 8 over 50 as a fraction. Now, I can write this as a fraction, I can write it as a decimal, I can write it as a percent. It doesn't specify which way to do this. I'd prefer, since it doesn't specify one certain way I'm supposed to do this in, I'd write it in all 3. So I'm going to write it in simplest form, fraction form. This is going to reduce down to 4/25. I'm also going to write it as a decimal. So as a decimal, 4 divided by 25, that's going to give me 1600ths. So that would be the decimal for the relative frequency. And then, of course, 2 places to the right to get my percent. So then as a percent, that'd be a 16% chance that it was going to land on a 2, or that you were going to draw out a 2. So that's the 3. Sorry, that was the 2. Okay. Now I'm going to do the relative frequency of the 3. Okay, so how many favorable outcomes was there for 3? 14. Out of, again, still a total of 50, right? So 14/50, I'll reduce that down. That's 7/25. Again, I'll do the decimal. 7 divided by 25 is going to give me 2800ths. Decimal 2 places to the right, or timesing by 100, that's going to give me a percent of 28%. Okay, and so there's my relative frequency of pulling out a 3. Example 2 says the frequency table shows the results of a survey about favorite types of vehicles. We're going to find the relative frequency that a randomly selected person's favorite vehicle was either a car or a truck. So car or a truck. I'm not just looking at one, car or truck. And this time it does specify that I'm going to write this down as a percent. And it does say we're going to round to the nearest whole percent. So first of all, I'm looking at car or truck. So car was 22, truck was 15. It's an or, so I'm going to put those 2 together. So 22 plus 15 is 37. So that's our favorable that we're looking at. I'm going to need to total these up to figure out how many total outcomes there was. So 22 plus 15, yes, the car and the truck, that's part of the total, right? 22 plus 15 plus 11 plus 17, that's going to give me 65. So that's my fraction. Now, it said to write this, it specified this time to write it as a percent. So I'm going to take that 37 divided by 65, okay? It did say I'm going to round this to the nearest whole percent. So I'll just write down 3 decimal places for right now. So as a decimal, 569 thousandths. And then move your decimal 2 places to the right, right? So it'd be 56.9, but it did say round to the nearest whole percent. So that'd be 57% for the nearest whole percent. Okay. Example 3, we have a graph that shows the results of a survey about favorite hobbies. Find the relative frequency that a randomly selected student's favorite hobby is reading reading or sports. Again, so I'm looking at both of those again. This time it specifies that I'm going to write this as a fraction as opposed to a percent or a decimal. So I'm looking at reading. So reading was 10, sports was 14. Add those together because I'm looking at both. That's 24. I'm going to have to get the total, right? So 10 plus 14 plus 9 plus 5 plus 12. It's going to give me 50. And then again, this time it said the fraction, so of course I'd want to simplify this down since I'm writing this as a fraction as opposed to a percent or a decimal. So 24 over 50 is going to reduce down to 12/25. And so that would be the relative frequency as a fraction. Okay. All right, last two. So example 4 here says a random selection of students was asked about their favorite meal, what their favorite meal is. The results are recorded, the relative frequency in the graph. What's the experimental probability that a student chosen at random likes breakfast or lunch most? So honestly, we still, here they're giving us the relative frequencies, and so it's asking for the experimental probability. Well, those relative frequencies, that is going to be my experimental probability right there. Now, I will specify it does say breakfast or lunch, so I'm going to have to total those up. But since they already gave me the relative frequency, they're essentially giving me that experimental probability already. That's essentially really what that relative frequency is, so don't get thrown off by that vocabulary. So breakfast, I was looking at 25 hundredths. Lunch, looking at 3/10, right? So we're talking about both of those, so I got to add those together. That's going to give me 55 hundredths. Now, if you notice, I'm not writing this as a fraction this time. I'm not writing that ratio because, again, they gave me the relative frequency already, which essentially is giving me that experimental probability that they're asking for. Now, I didn't say how I had to write it, fraction, decimal, percent. I'm going to go ahead and write it in fraction form, and decimal form, and percent form, just because it doesn't specify how, so I'll just write it all three ways. So 55 hundredths, of course, would be my decimal form. Then as a fraction, right, it'd be 55 100ths, but that's going to reduce down to 11/20ths. And then as a percent, it'd be 55%. Okay, example 5 says a town had rain on 138 days out of the last 365. Based on this relative frequency, how many days can be expected to have rain out of 30? Okay, so it's 138 ways that rain happened, right? Over a total of 365. So we're looking at a year. And so they're saying, okay, so based on that, well, then how many would I expect out of the next 30 days? Then we can use a proportion to solve this. Okay, so I'm comparing the days of rain to the total days. So remembering back to a proportion, so compare the same thing on the other side. So I've got rainy days to total. Well, so I want to know how many days it rained out of 30. So I'd put that 30 down here, solve that proportion, use cross products to solve it. So I'm going to take 138 times 30, divided by that 365. I'm going to get my answer. Now, I get 11 3/10 if I round, right? It's how many days can I expect to have rain out of 30. So I'm probably not going to be talking about a partial day here. So it's 11 3/10, so I'm going to bump that down to the nearest whole day. So I would round that to 11 days. So X is about 11. So how many days can I would expect rain on 11 out of the 30 days?